The purpose of this video is to start a discussion about how C stores information. In this series of videos, we'll use a couple of example programs to talk about how the call stack holds local variables, how parameters get passed, how memory gets allocated, and what pointers really look like. So the first thing I'm going to do is set up the project in CLion. So I say new project, and I say I want a C executable. I don't really care about the version of the compiler right now. I need to create a folder to put it in, so I have a workspace, and I'm going to create a new folder and name it what I want this project to be named. And I pick that as the project folder and tell it to create it. And that creates a project with a little hello world piece of code. I'm going to copy and paste our example project over top of that. And when I watch it run, you can see the output down here. Before we go any further, let's take a minute to look at that code. This is the main function. Main is the function that gets executed when you run a C program. There are two ways that you can declare main, but this one allows for the most functionality, so I just use this one all the time. We'll talk about those arguments in a later video. The only purpose of this code is for us to be able to look at memory to see how C allocates space for variables. So we just put some patterns in the data so that we'll be able to find them in memory. In this function, there are 3 local variables, an array named x that holds 10 integers, and 2 integer variable names, whole and whole2. This part of the code just fills those variables with known values, so we'll be able to find them in memory. It fills the array with the values 0 through 10, and then puts 42 and 43 into whole and whole2. The last line is just there so that we can put a breakpoint on it and go look at the memory. I want to show you some ways that you can look at variables in CLion. So let's put a breakpoint here. Then go and run it in the debugger. In the variable tabs here, you can see the values of our variables. X has the values 0 through 9. Whole and whole2 have 42 and 43 respectively. You also see argc and argv. Those are the parameters to main. Again, we'll talk about those in a later video. The C compiler stores local variables on the call stack. You can see the call stack in the lower left corner. Right now, the only function that is in progress is our main function. The standard debugging tool for C is GDB, and CLion gives us the ability to enter GDB commands directly in this GDB tab. That gives us, among other things, the ability to look directly at memory. So let's use that to look at how our local variables are stored in memory. We know that the register RSP points to the top of the stack, so we'll use that address to look at the memory locations holding the stack. The command to look at memory is X for examine. We follow that with a slash and the number of words of memory we want to see. I want to see them in hex, so I follow that with an X. Then a space, and the address I want to start with. And I can use $RSP to tell it, go get the address that is currently in RSP. Before you get overwhelmed by all of those numbers, remember that memory is just a sequence of spaces where we can store something. They're numbered, and we call that number their address. That's how we find them. All of these numbers start with OX. That's GDB's way of telling us that they're being displayed in hex. This is showing what is in every word of memory. The number on the left is the address of the first word in that row, and then there are 4 words of memory displayed. The address is always displayed in hex. The address of words are 4 bytes apart because a word is made up of 4 bytes and each gets its own address. So each row takes up 16 addresses. C really likes to do things on 4-word boundaries, and we'll talk about that more later. So the stack pointer always ends in 0, and each subsequent row of this display also ends in 0. Remember, we're thinking in hex. So pause and look around for a minute to see if you can find all 3 of our local variables, x, whole, and whole2. Remember the values that we put into them to try to find them. X is filled with the numbers from 0 to 9, so it is here. 42 in hex is 2A, and 43 is 2B, so whole is here, and whole 2 is here. There are some other things to notice here. First, there's clearly other stuff stored in our stack. See all these values between our local variables? Second, these values that start with 005FF look a lot like the addresses in this area of memory. They're actually pointers to other things in the stack. We don't need to know what they are right now, but we'll explain them in the next video. CLion also gives us another way to dump memory with this Memory View tab. Here, I just put in the address where it should dump memory from. The only thing that feels weird here is that it's displaying the bytes in the order that they're addressed, and the bytes within a word are addressed from the bottom. That means that each word is displayed in reverse. Our 42 is displayed as 2A, followed by 3 bytes of 0, while its value is 3 bytes of 0 followed by 2A. And remember those pointers? They're reversed too. So this is the pointer 005F, FEE0, and it points here. You can also see in this view that the addresses are really twice as long as what was being displayed by GDB. So in memory, they also have a whole word of zeros that is part of that address. In the next video, we'll see more about how the call stack and parameter passing work.